Hello everyone, welcome to Curious Farmer. So today we'll be discussing about rheology part 2. In the initial part, if you have watched the previous video, we had done some principles, the basic fundamental principles and concepts. Yes or no, like what is viscosity, what are the units of viscosity. Then we have done about the principle called how temperature affects density and viscosity. We have done kinematic viscosity, applications of rheology, Newton's law of flow, what are Newtonian system, non-Newtonian system. Okay, Newtonian system is what we had covered in the last part. If you have not watched the video, you can go back to that part and then come on to this part to have a better understanding. So today we'll be continuing with the next part. Here in this we'll be discussing basically about the non-Newtonian system and the type of flow exhibited by them. So coming on to non-Newtonian systems. So non-Newtonian systems, if you see, these are mostly exhibited by the liquid and the solid dispersion like colloidal solutions, emulsions, suspensions, ointments. So what happens is that these materials, when you analyze in the rotational viscometer and when you plot the results, you get a variety of consistency flow. Okay, and depending on that, we have three types of flows which have been recognized. Yes or no? So first, non-Newtonian system, majority of those which do not follow the Newton's law of flow. Yes or no? What was Newton's law of flow? Newton's law of flow was that the shearing stress is proportional to the rate of shear, which was given by the proportionality constant, which was the coefficient of viscosity. Yes or no? This was Newtonian system. But when it comes to non-Newtonian system, they won't obey the Newton's law of flow. Correct? Yes, it is exhibited. This application you should know which system exhibit the non-Newtonian flow, which we already mentioned, the emulsion, suspensions, ointments, colloidal solution as well. The three types of flow being exhibited is the plastic flow, pseudoplastic flow and dilatant flow. So this three type of flow is been exhibited by the non-Newtonian system and this will be discussing in this session. So starting with the plastic system. Plastic system, first of all remember, it is also called as Bingham bodies. What is it called as? Bingham bodies. So plastic system is a type of a non-Newtonian system. Why it is non-Newtonian system? Non-Newtonian system. ये क्या दिख रहा है? What can you see here? What can you see here? Can I call them as floccules? Can I call them as floccules? These are floccules. Correct hai? Now I will apply some shear stress. Okay, I will apply some shear stress. So see, this particle started moving, but if you see that these particles are again coming to the same part where they were. Like you try to break their floccules, but again they are coming to the same position. Yes or no? But what if I apply more shear stress or if I apply more force? Because these floccules if you see, they have some van der Waal forces. They have some van der Waal forces associated with them. These are the forces which we want to break so that these floccules will become separated. Yes or no? Yes or no? So flocculated system mein, if I apply force above a certain amount, can I say that these particles will get separated like this? Yes or no? Yes or no? So this force above which this floccules break and they will form this uniform, like they will get dispersed and the floccules will be broken. This force above which you get this is called as the yield value. It is called what? Yield value. Yield value is nothing but the force above which earlier it was what? It was a non-Newtonian system, right? But can I call this as elastic system? Can I call this matlab agar yield value के below it, suppose this is the yield value, below the yield value it was elastic, मैंने थोड़ा force apply किया, okay, they moved but again they become floccules. Correct? Yes or no? But if I apply above yield value, what am I getting is that the floccules got broken. Yes or no? So this is an elastic system. So, and this is what? This is what? A plastic system. Yes or no? So this is elastic system, as I have mentioned. This is a Newtonian system now. Newtonian system is what? They are uniformly dispersed if you see these particles. And this system will now obey the Newton's law of flow. Yes or no? This will obey now the Newton's law of flow. So the plastic system or the Bingham bodies exhibit this kind of behavior. So initially below the yield value, they will have elastic, they are elastic. But above the yield value, they will become Newtonian system. That means they will exhibit Newtonian type of flow. Am I right? Yes or no? So this occurs in the concentrated, this is important, occurs in the concentrated flocculated suspension. So concentrated जब होता है flocculated suspension, so you will get something called as yield value, and you apply the force above the yield value, you will get a Newtonian system. So there is a van der Waals force of attraction between them that keeps this flocculus intact. This is more viscous. Am I right? This will be more viscous, right? It's flocculated. It will be more viscous. Yes, more the flocculation, more the yield value. मतलब जितना ज्यादा floccules होंगे, अगर ये floccules इतने से अगर और ज्यादा हुए floccules, तो ज्यादा force apply करना पड़ेगा to break the floccules. Correct है ना? If you have more unity, more people you need to break that unity. Correct? So that is how it is. If the flocculation level is higher, the higher will be the yield value. Compared to Newtonian system, obviously Newtonian system compared to this will be less viscous. Yes or no? So this is a basic system. Plastic system, Bingham bodies बोलते हैं. It depends on the concept called as yield value. Below yield value, it will be elastic. Above the yield value, it will be Newtonian system. Below the yield value, it will be having van der Waals force and it will be having more viscosity compared to the above the yield value where it will be having less viscosity. Yes, do not forget this point. A very important point that you have to consider. High the flocculation, high the yield value. Understood? So this is a graphic representation. When you plot a graph of G, that is the rate of shear versus the shearing stress, you get something like this graph. This is nothing but the yield value. Till here, you will see that it is having an elastic flow. Elastic flow है. इसके above, it is a Newtonian system. Newtonian system की एक खास बात हमने देखी थी that it follows a straight line graph. Straight line, yes, and this will be constant. The slope of this, इसका अगर slope लो, that will be constant at any point. Am I right? So below the yield value, it is elastic. Above the yield value, it is Newtonian system. So this is what we have discussed. The slope is given by the term. Slope of the rheogram is called as mobility. इसका slope को mobility बोलते हैं. ठीक है? And the reciprocal of this is called as the plastic viscosity, which is U. So slope here that you will get is not viscosity, but it will be mobility. Yes or no? And inverse, you know, the inverse of this is the viscosity. So viscosity will be completely opposite. Inverse, reciprocal. So this will be the formula. So when you calculate the plastic viscosity, what do you get? It is the force, that is shearing stress upon rate of shear. But the shearing stress is nothing but this shearing stress is the F minus the yield value. Correct? Because from here what you are getting is this is not what you want. From here you are getting the Newtonian flow. So it is F minus this F. So we have to minus this F. Got it? So this is a formula. You have to remember what is mobility, what is the formula. So a plastic system resembles Newtonian system at shear stress above the yield value. I hope you got this concept. Coming on to the concept of pseudoplastic system, which is also called a shear thinning system. Now the shear thinning system, why it is called as, we'll discuss. So what is happening is that it is usually seen in the natural and synthetic gums like acacia, tragacanth, sodium alginate, methyl cellulose and sodium carboxymethyl cellulose. Now if you see here, what is happening is these polymers, these are all polymers, this gums, acacia, these are all polymers. These are entangled form में होते हैं, yes, entangled होते हैं. Correct? There is a physical entanglement. But when you apply, yes or no, when you apply that force, okay, what will happen is that this will get aligned. They will get aligned in the direction of the flow. So earlier they were like this. Now they have got aligned in the direction of this flow. Yes or no? They have got aligned. So because of that, if you see earlier when the floccules were there, there was more viscosity. Here also when these polymers are entangled, the viscosity is more. But when you apply the shear stress, they come to thin out. So there is release the liquid. They release the liquid which is there in them, and that is called decrease in the viscosity. So this is a shear thinning system. That is the pseudoplastic system which is usually seen in the gums. Whatever I am telling you, the examples, the concept is very important when it comes to the entrance point of view as well as the semester point of view. Hopefully you got this. Coming on to the graphic representation, this will be the graph. Now it's a pseudoplastic system. It is nowhere Newtonian system. It doesn't show Newtonian system. Newtonian system shows straight line graph. This is entirely a curve. This is entirely a curve. There is no straight line. No straight line means what? At every point, the slope is different. This bit slope is different. This bit slope is different. This bit slope is different. The slope is not constant. Yes, so usually take a tangent. Tangent to this, you get the slope. Yes or no? So it is given by the graphic representation again, this which you already know the formula. But here the difference is of one thing. For Newtonian system, this was 1, right? N is equal to 1 because we used to write the formula of this. But now for here, we get some formula like this. When you convert into logarithmic form, you get a formula like this. And N becomes more than 1 for pseudoplastic behavior. N is equal to 1 for Newtonian system. But for pseudoplastic system, N becomes greater than 1. Yes or no? So that is the only difference. Jitna zyada it goes, so this is a line. Consider this is a line, this is 1. As the more it goes away from 1, like more, like 2, 3, 4, the more pseudoplastic behavior it will exhibit is what we get from this value. The more the value above 1, the more is the pseudoplastic behavior. So I hope you got the graph. It's not a straight line graph. Yes. Hopefully you got the concept of plastic and pseudoplastic system. Pseudoplastic is usually seen by the colloids or the polymer solutions like tragacanth, natural gums, hydrophilic colloids which are solubilized in water. Yes or no? Don't forget that they are shear thinning system. Yes or no? Because that is a major difference. Okay? You will come to know when we go to the next slide. Okay? Coming on to the next part, that is dilatant system, which is called as a shear thickening system. So this is a shear thickening system. Why this is a shear thickening system? First of all, coming on to the example that we have already seen. What is the importance of example? Now, if you see here, it is usually exhibited by high concentration. Okay, fine. Above 50%. Okay, again important point. 50% or above. Deflocculated particles. Flocculated कहाँ पे मिल रहा था? When the particles were flocculated, what behavior it was exhibiting? Plastic flow. When the particles were like in the form of polymers, okay, what behavior you are getting? Pseudoplastic. Now when you have deflocculated, that to concentrated greater than 50%, then you get is dilatant flow. Am I right? You got the basic difference between these three systems, who exhibits what. So when there is highly deflocculated system, okay, this is highly deflocculated. These are not floccules. There is no floccules. And this, it is highly concentrated. If you see, it is so concentrated. There is a very less space in between. Yes or no? Are we getting this thing? So this, can I call this as a closed packed system? Can I call this as a closed packed system? Here if you see the void, ये जो void space है in between, this void space is also less void volume. And the vehicle, जो ये vehicle है red color का, can I say it is sufficient to just keep them separated or just to wet them completely? इनको इतना sufficient है कि सबको cover कर ले, उतना vehicle है, sufficient vehicle. Am I right? अगर कंसिस्टेंसी की बात करो तो इधर कंसिस्टेंसी थोड़ी कम है, विस्कोसिटी थोड़ी कम है यहाँ, ठीक है. सो दीज आर डीफ्लोक्युलेटेड, इसलिए इनकी विस्कोसिटी थोड़ी कम है, ठीक है. कंसिडर कर लो इसमें एग्जांपल, एक सस्पेंशन है स्टार्च का, स्टार्च इन वाटर का सस्पेंशन ले लो, ठीक है. ये एग्जांपल ले रही हूँ मैं. अगर ये घर पे भी ट्राई करो इफ पॉसिबल, So highly concentrated suspension बनाओ starch का, it will form deflocculated particles. When you increase the rate of shear, अगर आप shear rate बढ़ाते हो तो कुछ particles ऐसे हो जाते हैं, मतलब जैसे floccules जैसे बन जाते हैं. क्यों ऐसे बन जाते हैं? क्योंकि obviously when you increase it, they will move apart. They will move apart. But now if you see, vehicle is not enough to cover the entire particles. Am I right? मतलब क्या हो रहा है, पार्टिकल्स क्या हो रहे हैं, डायलेट हो रहे हैं. कैन आई से दैट अभी जो व्हीकल है वो थोड़ा इनसफिशिएंट पड़ रहा है ताकि हर एक जो पार्टिकल है उसको वो कवर कर पाए, कोट कर पाए. एम आई राइट? सो व्हीकल जो है, इफ यू सी, इट इज कांस्टेंट बट बिकम्स इनसफिशिएंट बिकॉज वॉइड वॉल्यूम यहाँ पे बढ़ रहा है. यहाँ पे वॉइड वॉल्यूम जो था, वॉइड वॉल्यूम नहीं था. ठीक है, देयर वाज पार्टिकल्स में क्या था, वॉइड वॉल्यूम नहीं था. यहाँ पे बहुत ज्यादा बढ़ गया है वॉइड वॉल्यूम. एम आई राइट? और उतना व्हीकल पूरा स्पेस जो है वो फिल नहीं कर सकता. इसके वजह से क्या हो रहा है कि अगर व्हीकल उनको पूरा कोट नहीं करेगा तो पार्टिकल्स कैसे इजीली फ्लो होंगे. It should lubricate the particles completely, right? This particle should be lubricated completely by the vehicle so that its flow increases. जो यहाँ पे था, बट यहाँ पे क्या हो रहे हैं, वो लोग सेपरेट हो गए, ये ऐसे फ्लॉक्यूल्स जैसे बन गए इधर फिर से, एंड दिस व्हीकल बिकम इनसफिशिएंट टू कवर और लुब्रिकेट द पार्टिकल्स, जिसके वजह से द रेजिस्टेंस टू फ्लो इंक्रीजेस. So can I say if the resistance to flow increases, the viscosity increases? It means that the viscosity is increasing. It is forming a firm paste जैसा. Correct है? So at rest if you see, these are closely packed. उसमें void volume भी बहुत कम है. यहाँ पे ये वाला जो है, यहाँ पे these are closely packed. ठीक है? And the void volume is also less. Vehicle sufficient है. ठीक है? But इस कंडीशन में आप उसको पोर कर सकते हो. बट क्या होता है, जब आप उसको shear rate बढ़ाते हो तो कुछ ऐसी चीजें हो जाती हैं जिसकी वजह से उसकी विस्कोसिटी बढ़ जाती है. ठीक है, जब आप shearing stress अप्लाई करते हो, द डायलेट, द पार्टिकल्स विल डायलेट. उसका इसलिए नाम टर्म क्या, डायलेट, एक्सपांड, डायलेट करते हैं. एंड दैट इज व्हाई दे फॉर्म दिस टाइप ऑफ पैकिंग जिसमें void volume becomes more, in the vehicle is insufficient to lubricate it, and the resistance to flow increases, further increasing the viscosity. That is why we say that it's a shear thickening system. एक बार starch paste try करो, जब वाटर में डाल दोगे उसको at high concentration and increase the rate of shear, क्या हो जाएगा is that at a time, मतलब it will become so thick, बहुत thick solution form करेगा वो. ठीक है, concentrated deflocculated particles should dilate and flow. Coming on to this part of graphical representation. इसमें अगर देखो, जो स्यूडोप्लास्टिक था उसमें हमें कुछ ग्राफ मिल रहा था ऐसे, इसमें उल्टा जैसा ग्राफ मिल रहा है. और ये क्यों मिल रहा है, बिकॉज यहाँ पे जो देखो तो विस्कोसिटी बढ़ रही है. कैन आई से विस्कोसिटी इज इंक्रीजिंग हियर? वहां पे कम हो रही थी, यहाँ पे बढ़ रही है विस्कोसिटी. करेक्ट है? सो यहाँ पे इफ यू सी n, difference is that pseudoplastic में n was greater than 1, but dilatant में n will be always less than 1. जितना वो 1 से, this is 1 scale, ये 1 है यहाँ पे. ठीक है, 1 से वो जितना माइनस में जाएगा, कितना जितना दूर जाएगा उतना ज्यादा dilatant behavior it will exhibit. समझा? More dilatant behavior as it goes away from 1. ठीक है, and as it approaches 1 it will become more of Newtonian system. Again इसका slope at every point will be different, it's not a straight line exactly, so it will differ. Graphical representation समझा? So viscosity is also not constant here, it is not constant. correct है? It is a graph which is passing through origin. Pseudoplastic का भी same था, dilatant का भी same है, passing through origin, but these are not straight line graph. The straight line graph, and the slope is not constant. Slope is not, sorry, here I'm making a polymer, so slope here is not constant. ठीक है? So this is a shear thickening system. This is the basic things that we should know when it comes to the plastic, pseudoplastic and dilatant system. I have explained you in a very short and crisp manner what is the difference. First you should know the name of all the flow, what are the alternative names, then you should know what are the examples. So examples are important. The formula for each, like if you see for plastic flow it differs because the yield value comes into picture. Here it becomes the parameter of n, less than 1, greater than 1. Correct? The graph, how the graph shows, interpretation of graph, yes or no? These are some major things that we should consider when it comes to, and the basic concept that you already know that you should be aware of. Okay, the basic concept. So this is again a conceptual understanding of the three type of flow exhibited by the non-Newtonian systems: plastic, pseudoplastic and dilatant flow. I hope you like this video, and thank you so much for watching till the very end. So if you like this video, please like, comment, share and subscribe, because your subscription for you would be free, but it adds a value to us and helps and motivates us to put in more videos. So thank you so much and hope to see you in the next part.